Low clap,
So remember, like
high clap.
amplifier is outputting a very noisy wave. Yeah. So what you want is using your peak detector to actually.
Initially, the capacitor is charged and no current is allowed to flow through the circuit. When a clap is registered by the microphone, the capacitor discharges through the microphone and into the ground. This allows the current to flow through the capacitor and into the amplifier, where the output voltage of the capacitor is then increased. This is done through a negative feedback loop where the output is connected back into the inverting input side, causing the voltage to increase. This output is then connected to the MOSFET, which acts as a switch on the BJT latch. Loud clap sends an amplified voltage above the threshold voltage, turning on the MOSFET, which completes the circuit. This is further explained in the BJT section. Threshold voltage of the MOSFET is responsible for small sounds not turning on the LED, and the BJT latch circuit is responsible for the LED to be turned on for a long time after the clap has been registered, and only turning on the LED when another loud clap is heard. It's all together.
Oh, that's fine. That's easy.
It's supposed to be voltage.
So this is how the BJT latch works. So when the battery is connected, it turns off the BJT on the far right, meaning no current goes through the 50K and 10K ohm resistor, making the MOSFET ground voltage around 9 volts, which turns on the MOSFET since it's above the threshold voltage. This lowers the VDS, which turns off the BJT in the middle, which also turns off the BJT on the left, turning off all the BJTs. This allows the current to only go through the path to the capacitor, which charges up to 9 volts. As soon as the button has been pressed, the capacitor is then connected to the BJT on the far right, turning on the LED. The far right BJT being on causes a voltage drop on the 10K ohm resistor, which brings the gate voltage below the threshold voltage, turning off the MOSFET. Since the MOSFET is now off, the current now follows the path to the middle BJT, then to the left BJT, which turns off all the BJTs.
The time circuit works by creating a timed response using an RC circuit and an NMOS transistor. When the button is pressed, it sends a voltage to the gate of the transistor, turning it on and instantly discharging the capacitor. Once the button is released, the transistor turns off and it allows the capacitor to begin charging again through the resistor. The charging rate or the duration that the LED stays lit is determined by the RC time constant. And this Schmidt trigger inverter monitors the capacitor voltage and controls the LED, and it turns it off once the voltage is high enough.
Hi, my name is Leslie Troy and I'm in the 86 section. This is my comparator circuit and it's connected up to the power supply, the waveform generator, and the oscilloscope right here. And right now it looks like this. And when I tune my potentiometer, it's either gonna go up to high, or when I turn it the other way, it's gonna go low.
Microphone.
Here's our circuit for the microphone. It's made up of a resistor, capacitor, and the microphone itself. The capacitor is initially at max charge, and when a clap is heard, the capacitor is allowed to discharge into the ground. Due to this, the current is allowed to flow through the capacitor and into our output. However, our output voltage is not very high, which is why we need the amplifier, which is made up of a resistor, inverter, and a couple of wires. The non-inverting pin contains the ground, and the inverting pin we have the resistor feedback loop and the output from our microphone. The feedback loop amplifies the output from the microphone to a usable voltage. The output is this green wire right there, which is then connected to the rest of our circuit.